I think we're going to go ahead and get started. We've got a full 60 minutes, so I want to make sure we use every little bit of time that we've got. Thank you guys so much for coming out for Build. Hope you're enjoying day 2. We are having a ball. Client really kicked the show off with a fantastic day of keynotes and sessions yesterday. And today, day 2 server, we're getting to have a lot of fun as well. This is using Windows Server 8 for building private and public infrastructure as a service clouds. My name is Jeff Woolsey. I'm a Principal Program Manager lead in the Windows Server and Cloud Division.
Hello, my name is Igor Edry, and I'm a Principal Program Manager in the Windows Server organization. And my role has actually been to own this private-public cloud scenario and coordinate that and make sure that it all comes together into what you're going to see here today.
So in case you were wondering, I know Satya talked about it a little bit in his keynote, and I don't know if you were in the Windows Server 8 kickoff session this morning with Bill and Mike. We talked a number of things about some of the core pillars in Windows Server 8. But I kind of wanted to, as we get this, there we go. As we get this started, one thing we want to make sure we start right off the bat is how we think about Windows Server 8 and the fact that it is cloud optimized. This really is the most cloud optimized operating system. It is the most cloud-ready OS we know we've ever delivered, and quite honestly, we're feeling good across the industry because of a number of things. And here are just a couple of the core tenets that we think about when we think about cloud optimized. Obviously, being able to enable multi-tenant. One paradigm I hear often is the Coke and Pepsi, or red and blue, or two different companies or corporations that simply have to deal, what happens if they ever get on the same network, or if they're actually the same virtualization host? How do you make sure that you provide the isolation, the security, the multi-tenancy in those environments? Being able to deliver high scale and low cost. People want to be able to, of course, provide the best density, utilize their hardware fully, but at the same time, they need predictable performance. They need to be able to meet SLAs and try and do this in a way that doesn't break the bank either. And of course, manageable and extensible. If you want to deliver at scale, good luck doing that with a GUI. It's why you've heard us say PowerShell, PowerShell, PowerShell. We introduced PowerShell a couple years back in Server 2008. It got quite a bit better in 08 R2, but let me tell you, with Windows 8, it is simply everywhere. So we've got a great story there. So one thing I like to think about is, with Windows Server 8, quite honestly, building your own private and public clouds just got a lot easier. So let's talk very briefly. There's one quick slide on cloud taxonomy and uses, because I always get someone going, are you talking about Azure? Are you talking about Office 365? Are you talking about the various different clouds? Are you talking about platforms? So let's talk very briefly about the different types of cloud taxonomy. So number one, software as a service, where the application is truly consumed as a service. A great example of that is Office 365. You can create an account, you can log in, there you have a finished service. You've got Office, you've got apps, Salesforce.com is another, and there are plenty up there where there's literally an application ready, a finished service ready for you available. You don't deal with VMs, you don't deal with the infrastructure, you don't deal with developing redundancy, you don't develop whether it's storage or network or any of those components. You're simply delivering an application as a finished service, and you're dealing with app-level assets. Platform as a service. So this is where the application platform developing cloud-ready apps. So again, this is Windows Azure. Okay, this is where we provide the platform in Windows Azure. It's fully redundant from a networking standpoint, from a storage standpoint, and then you build the apps that run on top of Windows Azure, but you don't have to deal with the fabric at all. You don't have to deal with redundancy, storage redundancy. You don't have to deal with geo-replication. If I have an application running in the US that I want running in Europe or in another geography, you can set that in Azure, and it will do all the replication for you and provide you those geo-replication services as well. And then there's finally infrastructure as a service, and that's what we're going to be focusing on today, which is, hey, virtual machines. This is where you're actually provisioning a virtual layer, a virtual substrate, where you're providing virtualization on top of some sort of hardware, and those VMs can scale, they're elastic, they're extensible. There's definitely concepts of self-service, of manageability, but again, you have to deal with the other things like portability, predictability, extensibility, federation. In this case, the cloud provider, really, they run the data center. It offers dynamic VM storage and network allocation. But the tenant owns the infrastructure and treats it as a server in the cloud. That's one way to think of it. And of course, people can do this and will do this on-premise. So when we think about the evolution of the data center, we can think back to, hey, 10 years ago, we all had physical servers. The answer, I look at virtualization, quite honestly, as we're paying for the sins of the 90s. In the 90s, the answer to everything was, well, just buy another server. Okay? You could be in a small 50-person company, and all of a sudden you got dozens of servers because they were cheap. They were easy to set up. They were easy to use. And you didn't, at the time, power, well, we'll get to power, but we need more services right now. And we had sprawl everywhere. But there was some, and the one real nice benefit of it was, quite honestly, hardware isolation. If there was a problem, oh, wow, the print server went down. Well, it's physical box number 10. You went over to physical box number 10. You knew where it was. You knew where all the cables were. You knew that everything was running on physical box number 10, and there you go. But you lost all the portability advantages, the flexibility advantage that virtualization gives you, and potential to scale dramatically rises. Now, instead of running 100 physical workloads on 100 physical servers, I can easily run 10 VMs on 10 servers, or even 20 on 5. Real easy on modern hardware. Not a problem at all. So now, server consolidation, as well as some scale-out capabilities, are provided with virtualization and heterogeneous server hardware. So it doesn't have to be exactly the same. But it gives you some more flexibility, but really is about consolidation. And one of the things that people ask me is, Jeff, what do you see as the difference between virtualization and cloud? And I say there's one thing you really have to think about. Virtualization, for a lot of people, just meant taking a physical server and converting it to a virtual machine and running it. But they're still treating it as a single entity. They're not treating it as a service. They're not managing it as a service. And as we start to move to a services world, we want to make sure that, honestly, a file server shouldn't be just a standalone file server. It actually should be a set of file servers to give you a scale-out workload that you manage and you think about at the service level, not at the VM level. And you should be managing it appropriately. If you're doing virtualization, for example, and you've got a 4-tier application and you have to go to every VM and you want to give it more memory and give it more storage and give it more networking to scale out, you're doing consolidation. You're doing plain virtualization. What you really want to do is go, listen, I've got 6 services that are providing this storefront, but instead of going to each one of them, adding more memory, adding more storage, adding more networking, dealing with IP addresses, you go to a management console that says, here's my service. I want it to scale up by 4x. And the management console does all the work with the virtualization platform and the cloud platform to really give you the ability to scale. And that's what really takes us to Windows Server 8 and infrastructure as a service. Because we want to provide, obviously, shared compute, storage, and networking, but we really have to deal with some of the bigger problems, the bigger challenges, multi-tenancy and isolation, converged network fabric. People are saying, look, I want to be, these I/O lanes are getting a lot faster. I can do a lot more with a lot fewer cables, and I'd like to converge all of that. Hybrid clouds. I want to be able to mix and match all of these things together and do what makes best business sense for me. As a developer, I want to go where my customer wants them to go, and hybrid cloud is definitely the case. There's certainly going to be assets they keep locally, and there's certainly going to be some assets that run in the cloud, whether that cloud is hosted in a hoster, whether that hosted on Azure, et cetera. But there's definitely be hybrid cloud. I mean, I look at it this way when it comes to hybrid cloud. I've had this conversation with customers, and they go, look, we're virtualizing everything. We love the idea of hybrid cloud, and I'm talking with the IT guy, and the IT guy's telling me, this makes all the sense in the world. But here's Phil, and Phil's sitting right next to him, and Phil is their lawyer. And Phil says, look, I don't care what you tell me. This is always going to be on-premise. I don't care whatever guarantees you want, it's always going to be on-premise. We're happy putting these other things up there, but Phil's here to tell me that everything's going to be running on-premise. So we know that no matter what we do from a technology standpoint, there's always going to be cases where someone's going to say, for whatever reason, for compliance reasons, whatever, I have something that's going to stay on-premise. And finally, we want to make sure that we have efficient infrastructure utilization. We are really using the hardware at full scale, full tilt, and we're trying best to get the inefficiencies out of the system. Automatic deployment, migration of apps. Stop thinking of VM as the layer of the app. We want you to be thinking about services, which is multiple VMs together, where you're actually doing things in concert, and we're actually managing at that level, not at the per VM level. And of course, scaling of network and storage to meet all of these new demands. With that, I'm going to pass it on over to you to go.
Thank you. So when we talk about Windows Server 8 being cloud optimized, we really talk about multi-tenancy, high scale, manageable and extensible. Multi-tenancy is really the core. If you are going to build a cloud, meaning you're going to have multiple customers running on your same infrastructure, same data center, there is no single tenant, right? You have to take care that to ensure that all of those different customers you have actually get isolations from each other, get the experience as if they're running on an isolated environment like in the past. So let's first try to understand what exactly we mean when we say multi-tenancy and talk about Windows Server 8 and building it as an infrastructure as a service. So imagine this scenario where you're a hoster and you have built your data center and you have like racks of servers in your data center, and you have two customers wanting to onboard into this data center. They both decided that they want to migrate some parts of their application, some workloads, into your data center. What you really want to make sure is that when you do that, they get secure isolation. That the fact that Contoso Bank here and Woodgrove both want to move their workloads into your environment doesn't mean that now, because they may end up running on the same server, they're not isolated from each other, right? So isolation, requirement number one that you have to take care of, and characteristic number one of a multi-tenant cloud. Second thing, you don't want to be constrained and say, in order to provide isolation, I have to put Contoso on this server and Woodgrove on that server, and they shall never meet. You want to be able to place any workload on any server and completely decouple the way your physical infrastructure is built from the way your logical workloads are being handed over to you to host them, right? So you have to be able to place any workload anywhere. You have to be able to move these workloads around. If you want to like balance the load on your data center, you have to be able to say, I want to move Contoso from this rack to that rack, because right now I'm going to service a rack and I have to take it down. And you don't have to worry, you don't want to be worrying about whether that means that in that rack there is a tenant that may not like the fact that you're going to put Contoso next to them. So dynamic placement. Last, you want to make money out of that, right? So you're providing some SLAs to your customers. You want to ensure by applying quality of service policies that you're actually giving them the guarantees or the service that they paid for in terms of network bandwidth, in terms of compute power, all of that stuff. And you want to make sure that you can actually charge for that. So you have to be able to show them what they got, and you have to be able to provide, to meter everything, and then to provide reports to them and generate your chargeback scenario out of that, okay? So secure isolation, anything can run anywhere on this data center, and I have to be able to guarantee and measure my service levels. That's how we think of multi-tenancy. When it gets to, let's talk about what exactly we've added to the platform, to Windows Server 8, to enable that kind of capabilities, to support multi-tenancy. So let's start with isolation. At the heart of that, it's the new Hyper-V extensible switch. We'll talk about the extensible part of it later, but at the heart of it, you have a virtual switch that basically does all of the routing, all of the traffic, network traffic between those different VMs, and can ensure that only those VMs that need to see other VMs can actually see them. And if a VM needs to be isolated from another, it's really isolated. It cannot see on the network the fact that another VM is actually running on the same switch. So you have the extensible switch, and within the extensible switch, we have isolation policies. When you place VMs on top of your infrastructure, you can say exactly what this VM is allowed to see, and at layer 2 of the networking, it will only see what you allowed it to do, okay? So we have the switch, it has isolation policies, and it has PVLANs, which we'll talk about in a second, as a way to basically isolate all VMs from each other if they're on the same switch with some variance. So secure isolation really introduces the first layer that makes it, like, this is the key requirement that customers will have if they want to move to your hosting environment. They will want to know that it's isolated, and we've made that possible. Second thing is dynamic placement. So now I'm the hoster, and I want to guarantee that, one, it's very easy for my customers to move to my cloud, and that I'm not bound by their topologies or their environments, and have to place certain workloads on certain servers. I want to be able to really freely place things around. How many of you have been in the network demo that Ross did in Mike Neal's session? Can you show me your hands? Okay, so Ross did some teaser, and we'll talk about this later. But this really is the feature that enables a customer to move his existing workload, existing network topology, existing environment as is to the cloud, to your hosting environment. Okay? Once you've done that and you've moved around, you want to make sure that everything can move around, and we've done tons of investment around enabling new VM mobility scenarios, which Jeff will demonstrate later on. And last, we have the new feature for cross-premise connectivity, which actually was also part of the demo that Ross did, this teaser, where we can show you how you can, once you've moved your network to the cloud, you want to still see this as an extension of your corporate network. You want to look at the cloud and basically elastically grow into that cloud. And in order to enable that, Windows Server 8 has features for remote connectivity that makes that possible. We will not drill down into cross-premise connectivity in this session, but if you are in the space of building networking equipment or remote access devices, stuff like that, there is a session 668 that talks about enabling the hybrid cloud and your opportunities there, what you can do to build on top of that story, to extend it, and basically enhance the scenario of enabling customers to move their workloads, their existing infrastructure, to some hosting provider that is running based on Windows Server 8. The third thing is quality of service and resource metering. There are, as part of the virtual switch, we have quality of service policies. So you can, on every switch port, virtual switch port, you can set policies like, I want to make sure that this VM gets at least a certain bandwidth and guaranteed bandwidth for VM. And you can also do the maximum bandwidth limitation, which is really about preventing some rogue VM, some rogue workload that you may have brought into your cloud from interfering with others. And we've actually had a lot of interesting meetings with customers, and customers have been telling us how important it is for them to be able to guarantee the minimum. But I think the best example was when we actually talked to some hoster in Europe, and he was telling us, when I'm a hoster, before the hosting world, I used to think of my network is the good one, and the evil is outside there, and I have to isolate myself from these things. Now I have the evil within. I actually bring customers on board. I run on my cloud workloads that may not be behaving correctly, and I have to worry about that. And these maximum guarantees are really what enables that to be enforced. Once we have enforced or guaranteed our service levels and guaranteed it by promising the minimum and ensuring that someone who tries to go over the maximum is not able to do that or actually not able to interfere with others, we need to be able to measure everything. And Windows Server 8 introduces a new feature called resource meters, where you can actually hook yourself on a VM and measure the activity that VM is doing in terms of memory consumption, CPU, network utilization, and measure that over time. And these metrics will be available to you to actually go into them and look at them. So if you're building a monitoring tool, you can read those resource meters. And those resource meters are actually maintained with the VM, even when the VM migrates. So if you had a VM and you decided to meter what it's doing, and some other process decided to migrate the VM to another server, those metrics go with it. So you have consistent metrics measuring what the VM is doing. And lastly, there are an enormous amount of new performance counter that gives you visibility into almost every aspect that your data center is doing, your cloud is doing. Now let's talk about what this means in terms of the network. So think about this. You have Contoso and Woodgrove. Both had some workloads that they want to move into the cloud. They want to move their infrastructure into your data center as is. And what they really want to do is want to make it easy. They don't want to do things differently just because they want to move their workloads into your cloud. They probably had this environment running in their existing infrastructure on site, and they decided that for some workloads they will keep them on site, but some others they want to move to you. and they don't want to do like reconfiguration of everything. They just want to move it as is. What you want to do, if the clicker would work, is that you want to place that anywhere on your data center, right? You don't want to be constrained by the network topology of your data center. The fact that you decided to divide your data center into different subnets, different racks, different locations, doesn't mean that you now have to instruct the customer how to prepare to move to your cloud. You want that to be completely decoupled, right? And both of you obviously want to make this as easy as possible, as flexible as possible, and obviously maintain isolation. So that's what you want. And when we talk to customers, to hoster customers, and we ask them, how can we enable that? And in today's world, they usually say, we need PVLAN support. What does it mean? It means that in today's world, where a hoster or infrastructure as a service hosting business is offering this kind of a VM for rent service to its customers, they basically take single VMs from different customers, and what they really want is everything is isolated from each other. I want to run VMs on my data center, and I want to make sure that no VM sees no other VMs, and PVLAN is the easy way to turn that on, to say, at the virtual switch, basically no one talks to no one. Just all VMs talk to the internet. That's easy. So guess what? Windows Server 8 actually introduces PVLAN support. The Windows Server 8 Hyper-V accessible switch has this capability, and what you can get to is all VMs are isolated from each other. We actually went a little bit further, and you can define a VM that can see all other traffic if you need that, and you can define communities, and this kind of starts to make things a little bit more complicated to manage. You get into the space of managing VLANs. And managing VLAN is good if you want to use that for your data center aggregation, separation of traffics. You want to VLAN for maybe your management traffic flow. That's fine. But when you get to onboard so many VMs into your environment, and you need to put VLANs for every VM, that doesn't scale. I don't know if anyone here has ever tried to manage VLANs, and if you've tried to do this at scale, but there is this theoretical limitation of 496 VLANs, and then there is this practical limitation of maybe 100, 150, and that's about it. You don't scale with VLANs. Another thing you don't do if you try to use VLANs for providing this migration to the cloud scenario is that you really cannot allow your customers to move to the cloud using their existing infrastructure and bringing in their own IPs. Again, when we talk to hosters and we ask them, okay, so you've got VLANs. Now, will you allow your customers to bring IPs with them? The answer is always no. We control the IP address management as a hoster. We'll give them the IP address. We don't even let them bring their VHDs on board because maybe they'll be misconfigured with IP addresses that we don't know how to deal with. So we're not really allowing those customers to move to the cloud with their existing infrastructure, existing environment. And we thought that we have to solve this problem. So the way we're going to solve this problem, or the way Windows Server 8 solved this issue, is by introducing network virtualization. So you've seen a demo, some of you, at the Ross's demo. And the easiest way to think about network virtualization is really by making the analogy into server virtualization. When you have a server and you want to move it to a virtualized environment, or maybe you want to run it like two different servers on the same physical servers, we're already used to think about the virtualization as the solution for that. We have a server, we run it in a VM, it gets the feeling that it owns the server, right? It can run side by side with another server that also thinks that it owns the server, the machine, and they are both isolated. So why not do the same for networks? Why not allow Woodgrove and Contoso to bring their network topologies as is with their set of VHD images or VM images, with their set of IP addresses, and just move them to run on top of physical network topology and completely decouple those. And the way we do that is by allocating different IP addresses for what the customers see, Contoso or Woodgrove. They would see 10.001 or whatever their internal address space is, and what the hosters see. The hosters actually gives them real IP addresses at the data center level that allows them to communicate with each other. And the management software that puts all of these VMs in place makes sure that you have a good mapping between these logical address space of IP addresses or the customer address and the provider address space, those IP addresses. If you want to learn more about that and the opportunities there, session 442 about Hyper-V network virtualization is the place to be. So during this session, we'll keep pointing you to the right session to follow up on opportunities that may be relevant to you. But specifically, network virtualization, to really understand how it works, that's the session to go to. With that, you have onboarded your customer to your cloud, and now the hoster wants to be able to move stuff around. And I'll hand it over back to Jeff to talk about what we've done there to enable that.
Thanks, Yigal. So one thing really interesting I want to point out on Hyper-V network virtualization is what you think some of the problems are that we're actually solving here. It's number one, it's the ability to flexibly move your workloads and get past some of the limitations that you may have run in architecturally from a network standpoint, either from a manageability standpoint, you've run out of IP addresses in a certain subset, so now a machine or a workload is pinned to a specific location, or the fact that, again, you really want to be able to move a VM anywhere. I mean, think about it this way. What happens when I've got a server here, and I've got a server in Redmond, and to each of those servers, they look like they're sitting in the same rack, but they're actually 2 states away. That's what Hyper-V network virtualization is about. That and the fact the IP address management problem is huge. I've talked to some of the largest hosters, quite honestly, in the United States. And what do they do for a living? They're networking focused. And what's their biggest pain point? Is IP address management. And now I'm saying basically, hey, he's running on 10.1.1, I'm running on 10.1.1, and we're from 2 different companies, and guess what? They can be hosted now with any sort of IP collision. So it really is some very game-changing technology with Hyper-V network virtualization, which really leads me to VM mobility quite well, because what is VM mobility? It's all about the flexibility of being able to move a virtual machine anywhere at any time. And in fact, one of the things I wanted to really bring up was the feedback you've given us. You've told us, number one, don't provide new features that preclude live migration. Sounds really obvious, but you'd be shocked. Okay? We can do feature X, Y, and Z, but the moment you say, oh, well, I can't live migrate the VM, customer doesn't care. Okay? You guys say, oh, I'm not interested anymore because that is now table stakes. I expect to be able to move a VM anywhere. I need that. It's now part of how I do business. The other one is I want to be able to securely move any part of a VM anywhere at any time with no limits. Okay? Shared storage. I don't want shared storage. Okay? Clustering. Well, I like clustering for high availability. I'm going to use it 99% of the time, but there are times where I don't care about clustering. I'll give you an example. You've got 10,000 servers, and you want to move a VM from server 1 to server 10,000. Okay? You're going to set up a 10,000 node cluster? Don't think so. What you really want to be able to do is move that VM from node 1 to node 10,000 and give you complete flexibility at any time, anywhere. So that's exactly what we decided to deliver. Now, when we think about virtual machine mobility, we're going to keep on having, of course, live migration with high availability. That will always be our number one recommendation because you get both. You get the flexibility to move a VM wherever you want, but if I walk up to a server and I yank out the power cable, then those VMs automatically fail over. That's still your best bet. You're still going to need shared storage for it. SMB live migration. Now we have the ability to move live migrate VMs using simply an SMB share. In this case, I actually don't need to set up clustering. We've talked to customers, and you guys have said, listen, there's some cases where I really don't need clustering. Maybe I'm on a scale-out IaaS server, and I not really worried about clustering. Okay, SMB will do it, and it'll do it at a dramatically lower cost. And then finally, what you saw demonstrated in the keynote, in Satya's keynote today, was live storage migration. So now I can have a VM that sits on this server, but the disks are on here, and then I move the disks over here, and then I move the disks over here, or then I move the disks to SAN number 1, or I move the disks to SAN number 2. The VM stays in place, but the storage moves around. And this is great for a number of different reasons. Number one, it enables storage load balancing. No downtime servicing. So for example, I get SAN 1 and I realize, oh man, I've got to do some maintenance on it. We're going to add some more disks to it or something. Let's go move it off to SAN 2. Or the SAN leasing scenario. You've had that SAN for now 5 years, and it's time the lease is up. And a lot of people say, you know what, I'm just going to redo the lease because it's just too much of a pain to get everything off. Well, make that really easy. No, no problem. Brand new SAN arrives. Now you can live storage migrate all those VMs. There's no downtime at all. And if you want to move it from direct attached storage to SMB to SAN, we don't care. No limits. That's what you want. That's what you're getting. The other thing is it leverages our new Hyper-V offloaded data transfer, or ODX. So for example, this allows us to take advantage of array-level optimizations. So for example, if I want to move a virtual disk from one location on the array to the other location on the array, why should I have to read that information in, copy it out to a different location on the array? Why can't I just pass it a secure token, let the array do the work for me? We're seeing in many cases easily a 10x performance improvement, if not dramatically more, depending on your array. So we can do a lot of things and leverage the underlying hardware. So for our hardware developers, our storage developers, you have got to get on this release and start testing immediately, okay? Because we got some fantastic capabilities in there. So how does live storage migration work? Well, number one, you've got the virtual machine reading and writing to disk. Number two, I want to move it to the destination disk. So what do we start doing is we start copying that VHD to the destination disk. Then step three is we actually begin I/O mirroring. So all writes happen to both disks. And the goal here is to bring both disks into synchronization. Once they become in sync, I can now, where is it? Got to wait for the clicker. Once everything is in sync, I can begin processing all reads and writes on the target, and I can get rid of the source. And it's all handled transparently. All of this is completely manageable and extensible through PowerShell. And again, we take advantage of offloaded data storage, so we'll take advantage of offloads at the array level. And of course, this is the one thing that I've thought about for a long time, and customers have always told us, they said, going back to what you said earlier, which is, look, I want to be able to move a VM anywhere at any time without any limitations. And it takes me really to this. Wouldn't it be great if you could live migrate a virtual machine from one system to another with just an Ethernet cable? Okay? To many people, this is the holy grail of live migration. This is what everyone's been talking about. It goes, look, you know, I get it. Clustering is great. I like it for high availability. SMB is good. It lowers the cost. But what if I just want to live migrate a VM from these laptops to these laptops? Wouldn't that be cool? We think so, too. So let me start off with scale for just a second, and then I'll get into VM mobility. First of all, a couple things I want to point out. When it comes to scalability, I've got the developer preview right here. And you can see I've got a VM here with 12 cores. Now, I'd show more, but larger scale-up machines are not a dime a dozen. If you want to go down to the show floor, you'll see that a number of our partners, I know at least one, is running a nice big scale-up machine with 32 virtual processors in a VM. So we'll support up to 32 virtual processors in a VM, up to 512 gigabytes of memory per virtual machine. And in terms of storage, we've done some pretty dramatic things on storage. We now support up to 16 terabytes in our virtual hard disks. And you may, for the guys that are noticing carefully, you actually see there's a new format. It's the VHDX format. This allows us to do some things in terms of scale as well as resiliency as well. But some massive improvements in scale. In terms of clustering, by the way, I'm not sure if this got, I know this got mentioned, I believe, in one of the keynotes, but I want to reiterate. 63 nodes and 4,000 VMs in a cluster. Best-in-class scale. And the reason why this is important is if you're thinking about delivering a hosted cloud infrastructure, clustering and high availability is something you're naturally going to want. That capability's in, and now we scale far and above and beyond anybody else in the industry. Now, in addition, one of the things I want to point out is from a processor standpoint, again, I'm running 12 virtual processors in the guest. One thing that's important to our developers to understand is that we're now reflecting and presenting NUMA topology within the guest operating systems. This isn't something we did in the past, because as we move up to larger scale-up VMs, this is something we need to do. As you develop scale-up applications, you want to make sure that memory and CPU allocations are being handled in terms of best locality and optimal placement to physical resources. The last thing you want is actually doing a bunch of NUMA hops that are going to impact performance. Well, we wanted to make sure that transparently this would just continue to run. So in Windows Server 8, if you've written your NUMA-aware applications and you're running them in Hyper-V in a large scale-up VM, we also present a NUMA topology within the virtual machine that closely matches and represents what's happening on the physical to make sure that we get best and optimal locality for NUMA resources. So that's an important one. Now, in terms of how we deal with, whoops, just, there we go. Get out of my way there. In terms of how we integrate with the physical fabric, let me go over here to the virtual storage manager, and you can see what we're doing in terms of Hyper-V and storage array networks. So we now have virtual SANs. Okay? So what I have in this machine is I have a physical host bus adapter for fiber channel. So there's the host bus adapter for my Contoso fiber channel SAN. Now what this allows me to do is gives me connectivity to my fiber channel storage fabric. Now what this means is I can now go into my virtual machines. I can go into their settings, and you'll see I have new hardware in virtual and Hyper-V. We've got the new fiber channel adapter. And what this allows me to do now is I can plug this into my virtual SAN, and now my VMs have access to the fabric. And in fact, I go here to the fiber channel adapter VM, and you can see I can set worldwide node names, worldwide port names, as you would expect to do in this environment. And in fact, I'll even go inside and take a quick peek here in Device Manager and show you, yes, lo and behold, in storage controllers, there is a Hyper-V fiber channel HPA. Now, what this does is opens up a whole bunch of new opportunities. Number one, you can now guest cluster using fiber channel. So now you can take those workloads that may have been sitting on physical machines for a little bit longer because, oh, they're attached pretty deeply into my storage fabric, and I want to move those into virtual machines, no problem. You can now do guest clustering. If you want to take advantage of MPIO for multipath I/O, Windows MPIO plugs right in, works flawlessly. And in fact, it's one of the reasons I'm showing Windows Server 2008 R2 on here, is to show you, hey, this works with existing OSs as well. And then finally, because we don't do any sort of packet filtering in the fiber channel level, your DSMs just work. So EMC PowerPath, guess what? Runs in a VM just fine. And if you want to develop storage management software, and in the past you may have wondered, well, is it filtering any packets? Is it actually going to work? Yeah, it's going to work just fine. But you should test it. You got the developer preview bits. That's what I'm showing here, the developer preview. So another thing to be thinking about is we've talked a little bit about the networking enhancements we've done. I'm going to go to the VM settings here. There's a couple things I also want to make sure we cover here from a scenario, again, of the hosted cloud provider. So things that customers are looking for and they want you to be able to provide is, number one, you have to be able to provide an SLA. So maybe someone says, maybe it's an internal organization, or maybe someone says, look, I am paying for X amount of megabits of bandwidth. So you want to provide then a minimum, okay? Or they get a maximum, and they're running at the bronze package. They want to move up to the silver package, great. You have the opportunity to change those caps, and all of this, of course, is completely and thoroughly extensible through PowerShell, and all of that can be done there. From a security standpoint, we talked a little bit about the importance of isolation and multi-tenancy. One of the things to point out is IPsec is definitely gaining in popularity. But when you run it in a virtual machine, there can be a little bit of extra overhead because now you've got to do that processing in the virtual machine itself. And we thought, no, this is a fantastic place for us to develop and do some work in terms of integrating with enabling IPsec task offload. So we can take advantage of this capability from the NIC and offload that so that we don't have to do any of that work in the CPU. So these are just a couple of the ways and a couple of the enhancements that we provided in terms of scale and in terms of fiber channel support within the guest. Now let's get to mobility. So again, I teased this already, but let's show it now. I want to be able to, quite honestly, move a VM from any server to any server with nothing but an Ethernet cable. This is it, boys and girls. No clustering, no SMB, no SAN, none of that. I'm going to move a virtual machine. I'm going to select Move Virtual Machine. I'm going to type in the name of the host, the DNS name. And you can see I'm given a lot of granularity about what I move. In fact, this is I think, a really fantastic foresight by a number of our PMs in thinking about this, was we didn't just think about this, oh, we're going to move all of the disks or all of it. Maybe you just want to move the configuration file. Maybe you just want to move the parent file. Maybe you just want to move just the snapshots or any combination thereof. This is incredibly granular when it comes to mobility from a virtual mobility standpoint. I'm going to keep it simple and move everything to a single location, and I'm going to move it to my new disk, which is really zippy fast. Whoops. going to put it in this folder. I'm going to click select and finish. And what you're seeing now is quite honestly considered the holy grail of live migration. I am now literally live migrating a VM from one server to another server, and there is nothing but an Ethernet connectivity. There is both direct attached storage on both of these systems. And the way we're doing it is quite simple. Number one, we start off with a live storage migration. So we start to move those underlying disks, whether you have snapshots or differencing disks or anything like that, all of those disks go over first. Then we go into an I/O mirroring mode. Okay, again, like we did with live storage migration, we want to mirror all the writes to both disks. Then once we've gotten the disk into a consistent state, then we start live moving the running state. So we start to move memory pages over. We keep tracks of any dirty blocks that change behind us. We make sure that we move all of those memory pages over until the complete running state is over. Once everything is finally over, we confirm that the entire live migration has occurred. Then we can delete the running state, delete the disks on the source, and we have just live migrated a VM without any sort of shared storage. And that is quite honestly, oh, it's already done. Sometimes it happens too quickly. And it's simply included in the box. So we think this is a tremendous opportunity for people who want to build management infrastructure, who want to be able to take advantage of, wow, there's a new capability here. I could plug right into this because, again, PowerShell is everywhere. Everything you see in the Hyper-V UI and more is all available from PowerShell. All right, so in terms of QoS and resource metering, I quickly showed you, yes, network bandwidth, you can set mins and max for network bandwidth utilization. In terms of resource metering, yes, we've done a really fantastic job to make sure that not only are we keeping all of your resource metering and not only keeping all of your performance counters, but we're keeping the history of that. So as you live migrate from server to server, because now we've made it easier than ever, the last thing you want is to actually move a VM from one server to another and lose all that history. You want to make sure you maintain all that history. So that capability is also built in to what we're doing in Server 8. In terms of Hyper-V resource metering, again, from a networking standpoint, let's talk about some of these rich capabilities we've added in terms of resource metering. So for networking, you can monitor the incoming and outgoing traffic per IP address range. So giving you some really nice granularity there in terms of what you want to monitor in terms of networking. From storage, we have a high watermark disk allocation. From memory, low and high watermark memory, average memory, and CPU, we have average CPU utilization. So really gives you, and quite honestly, this is the feedback we receive from you, is what are the things you need to do to make sure that when you develop management packages or you build a hosting infrastructure, what are the right counters that you need to deliver a service to customers? So this is what you guys have asked us for. So at this point, I'd like to bring up Chad Jones from Dynamic Ops to talk a little bit about some of the work they've been doing.
Thank you very much, guys, and thank you, everyone. Wow, a lot of stuff coming out in Hyper-V. I mean, it's really interesting to see that. Dynamic Ops, partner of Microsoft, is a cloud management platform that has leveraged Microsoft technologies extensively to build our system. We look at what's coming out in Win Server 8 Hyper-V, and all of the rich metrics, all of the data that Igal had talked to and Jeff had talked about. You know, we look at that and say, that's amazing, because that helps us as a partner really make great decisions about how we're going to do provisioning of virtual machines, how we're going to be able to gain efficiencies in using Resource Fabric, making sure we reclaim resources so that everything is working at the highest level of utilization. So because we rely on that kind of granular data, seeing the sheer amount of data that's coming out of Win Server 8 Hyper-V is very exciting to us. So what I'm going to show you today is a little bit about our platform, just very quickly, and then some exciting things that you can do with Win Server 8 Hyper-V information exposed through PowerShell to actually resize a virtual machine on the fly. Sorry, where's the
I'll switch on over?
No, actually, hold on.
Okay.
There we go. So just very quick primer on Dynamic Ops. We actually were started inside of Credit Suisse back in 2003, so kind of a reverse startup. Our founder actually was using Virtual Server at the time, had a bunch of different developers in different business units that needed to get access to virtual machines to accelerate their development of financial-specific applications. However, what he quickly found was that every single user that you represent at the top of the graphic here had very different needs, very different requirements. Every business unit had a different process and regulation to be able to get that virtual machine configured. to go through the operational layer and the fabric management layer, there's a very manual, task-heavy type of research that was necessary before you even touch the system to do any sort of configuration, right? So doing that took weeks sometimes to get them a virtual machine. So really, we viewed that as kind of an operational problem, and this was really before cloud was truly cloud. So what we did was built a platform that essentially took all of the information about a business unit and the user, all of the parameterization, all of the boundaries that that user had, and codified that into an automation layer that sat in between the virtual fabric and the actual user. So it knows exactly who that user is, exactly what they need to actually get their specific virtual machine configured for them. And it was actually able to reduce that weeks of time down to minutes, literally. So they spun the company out 2008, and we ended up getting some funding, continued on, and now we are the private cloud provider for some of the largest organizations out there in the financial community. But really, we're terming that operations virtualization, right? That's our specific layer inside of there. But that operations virtualization layer is really driven by the amount of data that we can see underneath there. So our platform, there we go. Our platform, as I said, was leveraging Microsoft technologies. We're built on Windows Workflow, on .NET Framework, on actually the very cutting edge and very deep into .NET Framework. WCF, the Entity Framework, ADO.NET, go down the list, SQL Server, and so on. But essentially, we're a model-driven architecture that has a centralized repository where we put a model for managing something inside of the system, virtual machines, physical machines, external clouds. And then when you actually perform some sort of self-service through our portal, it knows everything about the user that's making the request. What's the business unit? What's their process? Do they get to archive it on destruction of a machine? Do they get to be on a certain piece of fabric? Do they have external access? You know, all of those types of details we actually bring in. When it touches that data, it runs it in a generic Windows workflow engine, touches the fabric, and configures that virtual machine in the context of that actual user, and then presents it to them, and away they go. Now, beyond that, since we have a level of knowledge of the entire infrastructure, right, we're able to do some pretty cool things. First of all, provision exactly what that user needs when they need it, according to the process that they need it, but then also be able to reclaim resources that are not being used. Now, we do that in a couple of ways. The first way we do it is say, okay, virtual machines that are orphaned, let's go out and find those and then reclaim those resources, turn them into leases, and then eventually give the resources back. But almost as important is actually the over-configuration of systems. So if I'm a developer and, you know, hey, I want quad core and I want 16 gig of RAM, great, you know, but that costs money. You know, and maybe they only need about 4 gig of RAM, something like that. So, but you're holding on to those resources. So being able to right-size those VMs in an intelligent way actually is very important, because if I start scraping off a couple gig here, a couple gig there, all of a sudden that adds up to where I get a lot of those resources back into my environment. And that goes across network and storage, memory, CPU, all of those types of things. So what we've been able to do in the platform is be able to not only provide that reclamation capability, but provide an extensibility layer based on models that can tie in to any type of logic you'd like. So through our cloud development kit, we're able to build a model where we do connection to data and make that into a virtual table. We tie that to events and triggers, which ties to workflow. So if something ends up being a little too big, let's say, we can actually kick off a reclamation process automatically. We tie an activity to be able to do that, put security around that, and then that comprises our models for doing management. We put a group of those models into a module, and that's what we inject into our platform. At that point, we're able to auto-generate all of the other surround sound code you would normally need, as far as a RESTful API, the security around that, the tabling, all of those things are actually created by our platform. And now you have this level of flexibility inside of a system to take advantage of other systems or take advantage of new features coming in existing systems. An example of that is what we're going to show now inside of Windows Server, or leveraging Windows Server Hyper-V. Thank you. So what I have is my desktop here. And what I'm going to hop into first is my Windows 8 developer preview. Now, what we have running on top of here is what's known as our distributed execution manager. This basically takes the model, instantiates it, and reads the information on top of that Hyper-V host. Now, what we have inside of the Hyper-V host here are 3 basic machines. If we go into 7.1 here, go to settings, you'll see that under memory, we end up having about 2 gig. Well, you know what? Maybe that user uses 2 gig. Maybe they use less. We don't know, right? In this case, we think they're using less. But all of this data that is being exposed through Hyper-V, including new things like measured the VM's memory. What's the actual high watermark that they've been using for memory? And that really can inform a decision about reclaiming resources. Because if someone's got 16 gig assigned, but they're only using 2, that's something that you'd want to know and be able to fuel your decision. So all of this, of course, exposed through PowerShell. Now, what we're doing here is if I flip over to my DCAC server, our dynamic ops interface, this is actually the admin interface for our technology. Now, what we're doing is we have 3 different systems that we're aware of from that Hyper-V host. But if I go into the filter here, what I'm going to do is say, OK, let's filter on low memory utilization. And what that's going to do is tell me what percentage or what virtual machines are running at 10% of their overall memory. So which ones aren't even coming close to using all of their memory. So we have these 2 machines here. One of them is that desktop 7-1 that I had showed you. So what I'm going to do is go ahead and select both of those machines, hover over here, and say, all right, you know what? I'm going to send a reclamation request. It says, you know what? You guys aren't using the full amount of your memory. Do you want to downsize and save your business units some money, right? Again, this is drawing from that data that we have coming out of Hyper-V and performing some intelligence to it. So we'll go ahead and say, OK, let's send out the request. Now, what will happen, excuse me, actually, I need to send a different reclaim request. Let's see, reclamation request. Sent the wrong one. There we go. Here it is, reclaim virtual machine resize. There we go. And I'll go ahead and say OK. Now, that's going to send out a request via email that says, hey, you've been identified that you're not using your full amount of memory. Want to give it back. OK? Now, if I flip over into my view of what that actual user is. So if they went in and once they hit the email, this will log them into this system. I'm going to go ahead and refresh my desktop. Right? And I'll have a couple pending requests coming up here. Here's my reclamation requests. There we go. Open up. There we go. Waiting for user action. Let's see. Where's my pending request? It's not coming in. Approved to resize. There we go. So there's my request for 7.1. I'm going to go ahead and say approved to resize. I'm going to go back to my SharePoint. Oops. I'm going to go back to my SharePoint and say, OK, approve to resize. Right? So those are the requests that are coming to me. So now once that happens, our system is going back and saying, OK, it was approved by the actual user. Let's go do the work. Now again, that work is being done through PowerShell. So if I go ahead and flip back over into my DCAC server here. Oops, sorry, wrong one. My Win8 server. There we go. So now what you're seeing is that inside of here, we're actually doing the resizing of the RAM. And if I flip here and do a refresh, oops, and go to memory settings, you'll see right here now, 1024. So I actually resized that VM and got back that gigabyte that wasn't being used inside of the system. Now, going from 2 gigabyte to 1 gigabyte, wow, okay. But you can extrapolate that out and say, okay, if I have 16 gigabytes in a system, 8 gigabytes in a system, and it's only using 2 or 3, reclaiming 5 at a time across 100 machines, something like that, ends up being a lot of RAM, a lot of cost.
And it's a nice way to use resource metering and add that to a workflow action to make sure you're optimizing your business. So, and again, all of this is leveraging the PowerShell, the PowerShell infrastructure provided by Windows 8. That's really great.
Absolutely. In fact, here's our PowerShell script right here. You know, very simple for us to tie in to be able to manipulate, get the data, and then manipulate the data. I mean, very simple. We're talking about a few lines of code to be able to actually perform that action. But now inside of our platform, we've been able to wire up, let's see, move back over to the other one. We've been able to wire up inside of our system a way to take that PowerShell action and move that into a workflow that actually controls that reclamation process. So that's a custom reclamation process we were able to simply put inside of this workflow, put that up, inject that into our repository, auto-generate all of the code, and by the way, it auto-generated a secure REST interface that I can actually call. We called that through our portal, but you can actually call that directly through a script, directly through a web page, write it to an application to talk to it, and actually gain this level of control over the entire infrastructure. And we were able to do that because of the granular nature, the robust data that we're getting out of Win Server 8. So we're incredibly excited to see it, and I think it's going to be doing great things for our customers.
Thank you so much, Chad. Really appreciate that.
Thank you.
Thank you very much. All right, so again, we've talked about enabling multi-tenant clouds. We're moving to high-scale and low-cost data centers. I've already talked about a number of these things, but I'm going to quickly go through a couple of these. So I mentioned in terms of virtual machines, up to 32 virtual processors, up to 512 gigabytes of memory. I know this was mentioned earlier in another keynote, but we'll support up to 160 logical processors on the physical machine, up to 2 terabytes of physical memory. So yeah, we support some very large systems. We've done some really great work in terms of Windows hardware error architecture and RAS, Guess NUMA. For VDI scenarios, if you're developing scenarios in terms of VDI, one important metric that we've had for a while has been this whole concept of VP to LP ratios. And people basically say, how many virtual processors can I run per logical processor on the physical in the system? So for example, 8 virtual processors per core, or 8 server processors, or 12 to 1, or some sort of ratio like that. And I'm here to just say that ratio is gone. There is simply no ratio anymore. The ratio is, the number is, how much hardware do you have? How much memory do you have? How powerful is your CPU? How many gigahertz behind it? There's no scalability limitation in Hyper-V at all. There is simply no limit. When it comes to networking, we've done a tremendous amount of work to making sure we provide best-in-class performance. In Server 2008 R2, we provided virtual machine queuing. In Windows 8, we've taken this a huge step forward in terms of DMVQ, dynamic virtual machine queuing, and that'll be covered in depth in one of the networking sessions. Single root I/O virtualization. So as we look at mission-critical, massive scale-up workloads, okay, someone says, look, I see you've got 32 virtual processors. I see you've got tremendous amounts of memory in there. But what happens when I've got that really large SQL VM, or I got that really large Oracle VM, and I want to just dedicate a 10 gig eNIC to that bad boy, or even 2 of them and team them, okay? And I want to actually dedicate it to the NIC and actually present that NIC into the virtual machine. We've done it with SRIOV, single root I/O virtualization. And in addition, it's fully compatible with live migration. So there's no trade-off here. This is actually mapping virtual functions into a virtual machine, giving you native performance. It actually doesn't go through the switch. It actually goes directly from the virtual machine into the virtual function in the hardware. So you're actually not traversing 2 network stacks. You're not going through the switch. You're taking advantage of the virtual function, and you still get live migration. Awesome capabilities. RSS, RSC, IPsec task offload. Again, there's more networking sections that will go on to this in greater detail, as well as the storage offload capabilities. ODX, as well as RDMA, guest fiber channel, and 4K native disk support. If there's anything I want you to see is the totality of this release. If you're a developer and you're looking at networking, there are so many opportunities here to plug into the switch now. Okay? If you want to just create plugins to the switch, you can do that. If you want to create manageability, your own management interfaces, you can through PowerShell. If you're a hardware vendor, you want to take advantage of the array offloads that you're doing, we've got storage offload capabilities through ODX. And here's the quick screenshot. Yes, there's 32 virtual processors in a VM. And again, you can go down to the show floor, and you'll see it down there running on some big iron. In terms of high availability and data protection, Windows NIC teaming in the box. I'm thrilled out of my mind on this feature, okay? No more of having to deal with, well, let's see, I bought a server, it has Broadcom on the motherboard, but I just put in a PCIe card, oh, and it's Intel, and I can't team them because they're two different vendors. Not anymore. With Windows NIC teaming, we can team them both. Doesn't matter. You can team your Broadcom, you can team your Intel, it all just works, okay? And we support it, Hyper-V supports it, and it works great out of the box. Virtual machine fiber channel, I already talked about this. Yes, guest fiber channel in the guest. Hyper-V replica, didn't get a chance to talk about this, but we have replication in the box. So we can enable disaster recovery through our Hyper-V replication. I can replicate literally between two sites that I own, or if I'm a cloud provider and I want to provide replication services, I can now do that through Hyper-V replica. And again, this is an in-box capability. BitLocker and high availability. So this is actually a really key capability. You'll get the slides, I'll let you look at replica later. This is an important one I want to make sure you hear about. So you're a cloud provider, and in fact, you have good processes in place. You feel good about what you're doing. You've gone through certification. You spend a lot of time to make sure you're hiring the right people. You make sure you have good processes in place. When someone leaves the company or joins the company, maybe you do the background checks. You are doing everything for HIPAA, for SOX, you name it. But even though you do everything and you do all of those good things, what other safeguards can I use to protect my customers' data? Well, I'll give you a great example. Server hard disks appear on eBay. This is a real case. This was a large power company, okay? What happened? Data on their drives on their servers was lost. Contained proprietary company information, memos, correspondence, customer data, confidential employee information. All got out on eBay. People are buying disks and whoa, well, lo and behold, what's on this storage? Now again, this was a customer that was doing everything right. They had processes in place to degauss, to destroy the drives, to scrub them, to overwrite the data to DoD specs. They absolutely are a great company. They'd never had this issue happen before, but they lost a handful of these. Okay, so what do? And in fact, according to Gartner, about a third of companies use outside disposal companies to get rid of their PCs and servers. So even though you're doing everything right, how do you protect it from slipping through the cracks? Well, we think we've got a fantastic solution and a critical safeguard for the cloud with encrypted cluster volumes. So now you can actually BitLocker your Hyper-V servers. Okay? Now, in fact, you may be going, well, hold it. Couldn't I do that before in Server 08R2? You could, but not in a cluster. And so the problem is, well, we kind of had a mutually exclusive problem here. Basically, people wanted to BitLocker, but people deploy almost always in clusters because they want the high availability and live migration. Now we're saying, no, you can now deploy in clusters. You can take full advantage of getting encrypted disks. So in the case, had this customer had a clustered environment with Hyper-V with BitLocker enabled, and the disk actually appeared on eBay, and I got that disk, guess what? All they can do is format it. They can't read the disks off it. BitLocker is great. Government loves it. Military loves it. DoD loves it. If you're in combat, guess what they do? They BitLocker those disks because if they have to make a quick retreat, they stick a grenade on the server, but in case that grenade doesn't do what it was supposed to do, you still can't get the data because it's encrypted with BitLocker. That's how good it is. So BitLocker encrypted, supported for traditional failover disk, it's supported for cluster objects, and of course we've done work with Active Directory. And of course, all of this works with live migration. So you get all of the benefits, all the HA, and you get a critical safeguard for the cloud. Predictable network and lower storage costs. I just want to make sure we have two great sessions here. 439 on Quaz and Converged Fabric. We've got 444 and 446 designing systems for continuous availability. We're really going to go into storage, Hyper-V over SMB2, RDMA, spaces, thin provisioning, storage dedupe, as well as data center Quaz, DCB, and OS level Quaz. These are some fantastic sessions, and they'll go into these and really drill in deeper. Finally, manageable and extensible.
Hi again. So as you see, we're so excited about this that we are going over time by I don't know how much. So I'll try to expedite things. The last thing you really want to think about when you think about Windows Server 8 is that it's really manageable and extensible, and this is where your opportunity really lies. Customers love it, obviously, because it enables them to build their own tools for management or extensions. It enables them to get things from partners to complete their scenarios, their specific requirements. And Windows Server 8 is really open and extensible in a way that it was never before. So on the manageability front, everything is PowerShell enabled. Everything. Every feature you've seen, you can control through PowerShell or through WMI. And in fact, if you write management software and you write WMI providers, we actually make PowerShell automatically free for you, which is how we were able to internally increase our investment in PowerShell by so much. Just as like a small number, in Windows Server 2008 R2, we have about 150 PowerShell commandlets. In Windows Server 8, we have 2,300, or a little bit over that, actually. So everything is PowerShell enabled, and you have support for workflows to actually automate tasks across the data center, across different machines. We have the Hyper-V extensible switch, which enables you, if you're writing monitoring software, security software, you need to get visibility into the network of the cloud. You can write extensions to the switch. It's open, and you can extend that. And it's all based on standards. We have SIEM in the underlying. You can manage Windows Server using SIEM and WMI-v2. You can manage every Windows Server instance using OData, and we rely on standards when we were doing that, and Data Center TCP is just one example. In terms of PowerShell, as I said, everything is managed through PowerShell, and it's remotable through PowerShell. And there are actually two things here for you to think about. One is, if you build your own management tool, your own software to help cloud, to help organizations building their cloud, manage their cloud, then you probably want to make your product manageable as well through the same way so that they can automate it all. And if you go to session 604, you'll learn how to do that. And if you're automating a cloud deployment, session 565 will help you understand how to do that. And another example or another indication of the amount of investment that went into PowerShell is that we were actually able to build at Microsoft an environment where we get a rack of X amount of servers, some of them acting as a Hyper-V cluster, some of them acting as a file server. We put plain vanilla servers into the rack, and using a single PowerShell script, we can configure everything there. So we start with plain vanilla Windows Server. You end up with clusters configured, network configured, access to the storage, creating of share, permissions. All of that is done through PowerShell. So, and we actually intend to release those samples to you to help you understand how you could do the same. The switch is extensible. There are multiple ways to extend a Hyper-V switch. You can write capturing extensions. This is if you want to just look at network traffic and do stuff like IDS. You can write filtering extensions, things like firewall, security devices. There are actually two ways to do that. You can write a filtering extension in NDIS or using the Windows firewalling platform, Windows filtering platform. And you can write forwarding extensions. So if you are writing switches, routers, and you want to take control over the forwarding logic inside the switch, you can do that as well. All of that is being done. And actually, if you go to session 559, you'll see partners who have been working with us to extend the switch and enable new capabilities that are taking advantage of this extensibility mechanism. Plenty of opportunities for you here to take advantage of. Let's recap. Windows Server 8 is cloud optimized. What do we mean by that? It's multi-tenant using through network virtualization, dynamic placement, secure isolation, multi-tenancy, complete investment there to make it really possible to build multi-tenant clouds. It's high scale at low cost. We are leveraging hardware. So if you are a hardware vendor and you're building NICs, storage devices, etc., take a look at the areas where we are taking advantage of the hardware and make sure you do this. You provide these kind of solutions to your customers. And last, manageable and extensible. We've seen dynamic ops here taking advantage of the PowerShell to build management tools. And if you go to the Hyper-V extensible switch doc, you'll see how other partners are taking advantage of that for other scenarios. Last thing, so again, write extension. There are plenty of opportunities to you to build on. If you are a management software or building tools to help run and automate private clouds, if you're in the area of hardware or building systems, make sure you take advantage of all of the hardware dependencies, all the hardware features we are taking advantage of. There is a white paper coming out very soon, probably like end of this week or next week, that will explain all of that in more details and give you the right context around this whole Windows Server for Clouds story. So you have the link here to follow that like in the next few days. And go to the relevant sessions and explore your opportunities based on what you're interested for.
We thank you very, very much.
And
We've
thank you very
run
much.
way over time. If you have questions, we'll be happy to answer them right outside the door. Okay, thank you very much and enjoy the rest of the time here at Build.
Thank you very much.